Okay, this is our review 2.7. This should be a review that talks about everything we've done in Unit 1 and Unit 2. I would consider this to be the complete review. You've got a test that you did on Unit 1. You've got reviews in Unit 1. So you've got other materials other than just this review to look at. So solving. Solving equations. If they don't have square roots or fractions, I just want to set them equal to 0. So 3x cubed plus 5x squared minus 12x minus 20 equals 0. How do I factor? Is there a common factor? I don't see a common factor. My next question, I see 4 terms. The only thing I ever learned how to do with 4 terms was factor by grouping. So let's factor out an x squared, and I'm left with 3x plus 5. Copy down that minus sign. It looks like I could factor, so it'd be a negative 4. And that would leave me 3x plus 5 equals 0. So this is x squared minus 4. 3x plus 5 equals 0. Always be asking, is there another factor method? This is the difference of squares. So this final answer is x minus 2, x plus 2, 3x plus 5 equals 0. That's the final factorization, sorry. But they asked me to solve this. So I set each of these equal to 0. And I would get x equal 2, x equal negative 2, or when I set 3x plus 5 equal to 0, x equal negative 5 thirds. Those are the 3 answers for this problem. Number 2, is there a common factor? There is not. How do I factor this? This is a trinomial. So I need to find 2 numbers that will multiply to give me, what is 6 times negative 10? That is negative 60. And they will add to give me 11. So numbers that multiply to 60 and combine to 11, well, what are the factors of 60? 1 and 60, 2 and 30, 3 and 10, 4 and 15. 4 and 15, there's a way to make those combine to be 11. So if this was negative 4 and positive 15, those numbers multiply to negative 60 and they add to positive 11. So I'm going to rewrite this equation as 6x squared minus 4x plus 15x minus 10 equals 0. Now I'm guaranteed that I can factor this problem by grouping. The first 2 terms, I can factor out a 2x, and I'm left with 3x minus 2, plus the next 2 terms, I can factor out a 5, and I'm left with 3x minus 2 equals 0. So this is 2x plus 5 times 3x minus 2 equals 0. Set each of these equal to 0. When 2x plus 5 equals 0, that means 2x equal negative 5, or x equal negative 5 halves. That's one answer. When 3x minus 2 equals 0, 3x equal 2, or x equal 2 thirds. Those are the 2 answers to that problem. Number 3, I've got a rational expression. My big concern here, I have a fraction. I know the fraction on the bottom, that denominator, can never be 0. So x minus 1 cannot be 0. So if x minus 1 cannot be 0, then x cannot be 1. That is my restriction on this problem. X cannot be 1. Now, how do I solve this problem? You multiply both sides of this equation by x minus 1. The reason we do that is because on the left side of the equation, multiplying by x minus 1 is going to do the strategic thing of getting rid of the fraction. So I've got 12 equal x minus 1. So 12 equal x squared minus x. I would like to solve this by letting it be equal to 0. So let's subtract 12 from both sides. and here you get 0 equal x squared minus x minus 12. So that's just a trinomial that we know how to factor. I need two numbers that multiply to give me negative 12 and add to give me negative 1. That looks like a negative 4 and a positive 3. So this is x minus 4, x plus 3 equals 0. So x is equal to 4 or negative 3. Does this violate my restriction? No, does not violate the restriction, so these are my answers. So x equal 4 or negative 3, you could substitute in and guarantee those are the correct answers. Now I have one with a radical. Okay, what's the restriction? Is whatever is under the square root. So what's under here, it can't be negative. Okay, I can't take the square root of a negative number. So in this problem, x plus 5 is not negative. Okay. How do I write x plus 5 is not negative? That is x plus 5 greater than or equal to 0, or x greater than or equal to negative 5. So that's my restriction. X has to be greater than or equal to negative 5. Now, to solve this equation, I square both sides of the equation. So x plus 5 squared equals 6 squared, or x plus 5 equal 36, x equal 36 minus 5, x equal 31. You want to check this answer. Anytime you square both sides, you want to check your answer, especially the cases where you get two answers. But I can check this one pretty quick. If I plugged in x equal 31, 31 plus 5 is 36, square root of 36 is 6, so that is the correct answer. If I had obtained two answers here, I'd need to go back and check it and see if one of those was an extraneous solution. So solving inequalities with absolute value. Got a positive number here. Our strategy was to break this into two problems. First problem, 5x plus 8 greater than 18. Second problem, 5x plus 8 less than negative 18. Okay, so I flipped the sign of I flipped the inequality and the sign. Now I just solve this by subtracting 8 from both sides. I get 5x is greater than 10. Divide both sides by 5, x is greater than 2. Over here, subtract 8 from both sides, and I get 5x is less than minus 26. X is less than minus 26 over 5. Now, on a number line, which of those numbers is smaller? That's negative 26 over 5, and we've got 2. What does it mean to be less than negative 26 over 5? That's this condition. What does it mean to be greater than 2? That's the condition you see here. I'm looking at two intervals. So my answer in interval notation is negative infinity to negative 26 over 5, or 2 to infinity. Those are the two intervals that are the solution. So again, I'm not really grading the number line part. I want this final answer to be in interval notation, which is what you see here. Let's look at the next one here. X plus 5, absolute value, minus 1 less than 9. What I want is, I want this to be all by itself. In order to get that to happen, I add 1 to both sides. So x plus 5 less than 10. Now I break this into two separate problems. First problem, copy everything down just as you see it. Second problem, make two changes. X plus 5, flip the less than to a greater than, and you put a minus 10. And to solve this, you subtract 5 from both sides. X is less than 5. Here, subtract 5 from both sides. X is greater than negative 15. On a number line, which of those is smaller? That's negative 15 and 5. What does it mean to be greater than negative 15? That's this situation. What does it mean to be less than 5? So it looks like I have one interval there. The interval is from negative 15 to 5. Here I have a simple inequality. So 2x plus 7 less than or equal to 5x plus 9. If I subtract 5x from both sides, I get negative 3x plus 7 less than or equal to 9. Subtract 7 from both sides, negative 3x less than or equal to 2. Now I'm going to divide both sides by a negative 3, and I'm going to have to flip that sign. So I get x greater than equal to negative 2/3. So on a number line, if you had negative 2/3, greater than or equal to is a solid circle, shade to the right. This interval is negative 2/3 to infinity. Number 8, I've got a compound inequality. We found that the best way to do this was to break it into two problems. Here's problem number 1, and there's problem number 2. So negative 14 less than or equal to x minus 2, and x minus 2 less than minus 10. You just solve each problem. So if I add 2 to both sides, I get negative 12 less than or equal to x. If I read this from right to left, starting with the x, that says x greater than or equal to negative 12. So a lot of people would just rather read it in that fashion. Put the variable first. Here, add 2 to both sides, and I get x less than minus 8. So which of those is the smaller of the two numbers? That's negative 12. So on a number line, what does it mean to be greater than or equal to negative 12? Solid dot, shade to the right, less than negative 8. So less than negative 8, open circle, shade to the left. So that's one interval. That interval is from negative 12 to 8. Bracket around the negative 12, parentheses around the negative 8. Compound inequality with an OR. You just treat this as two separate problems. Y minus 10 greater than minus 6, 2y minus 4 less than or equal to minus 10. Add 10 to both sides. Y greater than 4. Add 4 to both sides over here. You get 2y less than or equal to minus 6. Divide both sides by 2. Y less than or equal to minus 3. So minus 3, positive 4. What does it mean to be less than or equal to minus 3? Shade to the left. Greater than 4, shade to the right. Two intervals from negative infinity to negative 3 with a bracket, and parentheses 4 to infinity. Those are the two intervals that you see in this situation. Now we go to reading graphs from polynomials. So what are the zeros of this function? So on your graph, you might want to mark it. They're 1, 2, 3. They're 4 zeros, or x-intercept. These are points. They have coordinates. So that's negative 4, comma 0. Negative 2, comma 0. 1, comma 0, and 3, comma 0. So those are the zeros, or the roots, or the solutions, or x-intercepts of this function. What would it mean to find where is f of x greater than 0? So the intervals on the x-axis where I'm above the axis. So here's the x-axis. This is the x-axis. So I'm looking for things that are above the x-axis. It looks like I've got 1, 2, 3 pieces of this graph that are above the axis. And it says greater than, not greater than, equal to. So this first interval, so you start over here on the left. So I am above the axis all the way until I get to negative 4. So from negative infinity to negative 4, I'm above the axis. And then it looks like I'm above from negative 2 to 1. Negative 2 to 1. And then it looks like from 3 to infinity, I'm also above the axis. So 3 to infinity. That's when I am above the axis. Now, it's going to ask me for where is this function less than or equal to 0. Okay, so I'm going to have some square brackets involved in this. So the intervals are going to be this interval here and this one here. There are two intervals that are going to make that happen. So the first interval is from -4 to -2 with brackets because it's less than or equal to. And the next interval is going to be from 1 to 3. Those are intervals where the function is less than or equal to 0. Similar concept here, I have a rational expression. So my graph has these asymptotes, lines that the graph will not cross. So if you notice, if you look at this problem, x minus 2x plus 3, the restriction is x cannot be 2 and x cannot be -3. Well, on my graph, there are special things happening at -3 and 2. That's where you see these vertical lines. So where are the zeros? It looks like the zeros are going to be, see, I have one right here and one right here. So -2, 0, and 4, 0. Where are the asymptotes? These vertical dotted lines my graph cannot cross. These are equations. It is at x equal -3 and x equal 2. And if you'll notice, these are the places where that graph is undefined, at 2 and at -3. So those are the equations of the asymptotes. Give the solution to where this function is greater than equal to 0. So where am I above the x-axis? Well, that's happening here, it's happening here, and it's happening here. Okay, so let's look at those intervals. The first interval, as I travel from left to right, is going to be from -infinity. Okay, and it goes all the way to the asymptote at -3. Okay, infinity always has a parentheses. At the asymptote, the graph is undefined, so it has to be a parentheses. It cannot be a square bracket. Okay, now let's look at the next one, greater than equal to 0. If you look at where it happens at -1, so that's going to be -1 with a bracket. Okay, and it goes all the way to the asymptote, which is 2. That will always be a parentheses. And then the next interval you see is going to be from 4 to infinity. And 4 will have a bracket. Okay, so 3 intervals where the graph is above the axis. Now they're asking me, where's the graph less than 0? So less than 0. And so if I look at that, there are places where that happens is going to be right here. And if you look at this spot here, there's 2 intervals where I'm less than 0. So that first interval goes from what, -3. So the first interval is from -3 to -1. The asymptote is always going to have a parentheses. The -1 is going to have a parentheses here because of that strictly less than. So from -3 to -1, and then the next interval goes from 2, which is the asymptote, to 4. So that's where the graph is less than 0. Okay, I want to go back real quick at the end of this review. Let's go back to the previous review, 2.6, and we skipped the last problem when we were getting ready for our quiz, but now we're able to do it. So it's the same thing with a rational. What are the zeros to this graph? -2, 0, and it looks like 3, 0. The asymptote is going to be at x equal 1. And give the solution. Where is this thing greater than equal to 0? So intervals where it's going to be greater than equal to 0, I see 2 intervals, okay? So that first interval is going to be from -2 over to the asymptote of 1. So square bracket on the -2 and a parentheses around the 1. And then that next interval is going to be starting at 3 and it goes to infinity. So that's where the function is greater than equal to 0. Okay. Now, I didn't ask it here, but if I had asked for where is this function, if I asked for where it was less than 0, if it's less than 0, you'll be looking at these 2 intervals that you see here. Okay.